Okay, here we go. We've gotten to question number 4. And here's some information. We get two graphs. I don't know if you guys can see this, that the resolution might be too bad on the output of the recording, but I'll put a link in the description where you can find the exam and you can follow along on your own screen. Right, so some more information. F of x is given, that's x squared plus bx minus 3, that's a parabola right here. And g of x is a over x plus b, so that's a hyperbola right there. And we are told that f has a turning point at C, and it passes to the x-axis at 1, 0 right there. D is also the y-intercept of both graphs right here, and E and J are the two other points of intersection of the two graphs. Now the vertical asymptote of G is at 1, so that's the hyperbola's asymptote right there. And that is all the information. Now let's start with question 4.1. So question 4.1, we are asked to write down the value of P. Okay, so the equation for g of x is y equals a over x plus p. And this is a hyperbola. Now what do we know about this value in hyperbola? That'll give us, that says it's to do with the asymptote, right? Now an asymptote is where a graph does not exist. It never touches that value. So for this, where's some problem here? Where would the graph not be able to exist? Well, if the bottom part is 0. So if x plus p equals 0, then we'd have a problem. Then we'd have an asymptote, or an undefined spot, which is an asymptote. Right? We can see here though, the asymptote is at x equals 1. So we can replace x with 1 and say 1 plus p equals 0. And that gives us p equals negative 1. So there's our value of p. Easy as that. Right. Question 4.2. 4.2. Oh, make a point. We have to show that a equals 3 and b equals 2. So let's start with the a equals 3 part. Again, it's this equation. That's where the a is. X, and we've seen that p is negative 1. Now to find a, we need to substitute a point in. Now which points do we know that lie on the hyperbola? We know that 1, 0 lies on there, but if we substitute 1, 0, we'll get a problem. We'll get undefined if we make x 1, so we can't use that point. We can try D. How do we know what D is? Well, we know D is the y-intercept, and we can see what the y-intercept is in f by just looking at the C value, which is negative 3. So here we know that D is the point 0 and negative 3. So we can use that one. So y is negative 3 when x is 0. Alright, so negative 3 equals a over negative 1. Multiply both sides by negative 1, and we get 3 equals a. There's the value of a. We also need the value of b. So that would be the other equation, which is y equals x squared plus bx minus 3. So again, we'll also have to substitute a point in for this one. Now if we use D for this substitution, then we'd get negative 3 equals negative 3, which is true, but it doesn't help us. So we want to use another point. And for that, I'm going to suggest this x-intercept of 1, 0. So we'll substitute in 1, 0, which means y is 0 when x is 1. 1 squared plus b times 1 minus 3. And that will give us 0 equals 1 squared is 1, b times 1 is b, minus 3. So 3 minus 1 equals b, which gives us 2 equals b. And there we have it. A is 3 and b is 2. For question 4.3, we have to find the coordinates of C, which is the turning point of the parabola. Now a couple of ways to do the turning point. I think the most common one would be to say that the x value of the turning point is negative b over 2a. Okay, so x equals, we know that b is 2, so negative 2 over 2 times what is a? A is the value in front of the x squared, and that is 1. So x equals negative 2 divided by 2, that's negative 1. That's the x value. Now to find the y value, we do f of negative 1. We substitute negative 1 into x, which will give us negative 1 squared plus 2 times negative 1 minus 3. What does that equal? 1 minus 2 minus 3, and that is negative 4. So our coordinate for C is negative 1 and negative 4. There we go. 4.3 done. Now we get to 4.4. So this is write down the range of f. The range of f. Alright? So what does range mean? Range is all the y values for which a graph exists. So if we look at this, so we can see f exists all the way here. Where does it not exist? It does not exist below this, below the c value. So if we draw in a little line there, anything below this, there's no graph. Anything above here, it is a graph. If you draw a line here, then you'd cross the graph. If you draw it here, you cross it. E doesn't matter how far up you go, because it goes all the way up on both sides. So anything below this does not work. Anything from C and up does work. So we already know this is the C value. Let's write down the coordinates here. So we know C is negative 1 and negative 4. So that's the y value, is the negative 4. So we know the range of y is y must be greater than or equal to negative 4. And that is for all real values of y. There's our answer for 4.4. Nice, we're going smoothly along. Next, let's look at question 4.5. So 4.5. What does that say? Determine the equation of the line that goes through C and makes a 45-degree angle with a positive x-axis. And we have to give our answer in the form y equals. So let's just see on the graph, what would that look like, sort of. So it has to go through point C, and it has to make a 45-degree angle. A 45-degree angle with a positive x-axis. Alright. So we know that's a straight line. So we know it's going to be y equals mx plus c. And something else we know is that m is equal to tan of the angle with the positive x-axis. So m equals, in this case, tan of 45 degrees. So that gives us tan of 45 is 1. So far we know that y equals 1x plus c. We don't even need to write the 1, but I'm just going to do it because we just worked it out. And then we can substitute a point. What point can we substitute? Well, they told us it goes through c, so we can substitute c. And c is negative 4 for the y value. X is negative 1, and then we keep c. So negative 4 plus 1 equals c. That gives us negative 3 equals c. So our final equation is y equals 1x minus 3. And there is our answer for question 4.5. Right, let's look at 4.6. 4.6. So 4.6 asks, is the straight line determined in this question 4.5, is it a tangent to f? And explain your answer. Well, we can see here it's not a tangent because it crosses through C and then again somewhere else. So that's not a tangent. If it was a tangent, it would look like this. Right? It would just touch the graph once, which is something like that. And for that, we'd have to have a gradient of 0 because it's exactly flat there. And we see our gradient is not 0, so it cannot be that. But let's see, there's another way we can prove this. The tangent touches only once, so if we can prove that these two equations cross more than once, then we've shown that it's not a tangent. So we know the one equation is y equals x minus 3, and the other one is x squared plus 2x minus 3, because b is 2, right? X squared plus 2x minus 3. X squared plus 2x minus 3. Alright, 0 equals x squared, then 2x minus x is plus x. And then negative 3 plus 3 is 0. So here we can factorize this into x and x plus 1. So then we get x equals 0 or x equals -1. Let me just write that slightly better. X equals -1. So we see the crosses in two spots, and on the graph, on our drawing, we can see that's true. At -1 right over there at C, and then at 0 again. So my drawing is obviously not accurate, but at 0 is the other place where it crosses. So we can see no, our answer is no. The graphs cross more than once. More than once. And that's it. That's why it's not a tangent. And then the last question for this video, 4.7. What color should we do that one? Let's do this. 4.7. Okay, the function h of x equal, I'm going to write this down in case you can't see, because this is probably quite important. So h of x equals f of m minus x plus q, oh, not g, plus q. Oh, sorry for the bad writing. Alright, and they say this has only one x-intercept, and that is at x equals 0. So if all of this is true, then we have to find the equation h of x, or we have to find, let's rather say, find m and q. Alright, so here is our question. Find m and q. So find m. Let's do another color for that. Find m and q. Okay, m and q. So this looks, yeah, m and q. Alright, so this is a transformation of the graph. So initially, the important thing here is we can look at the turning point. So initially the turning point was at -1 and 4. And we have to get the turning point to 0, 0, right? Because if a graph only crosses the axis, or only has one x-intercept at x equals 0, that means this is what it looks like. Only one x-intercept at x equals 0 means it looks like that, right? It only crosses there, only at that spot, at x equals 0. Alright, so let's just do that. Alright, so that's what our graph looks like. Now how do we change it from having a y-intercept, a turning point there? So it was -1, -4. How do we move it there? Right, so it has to go 1 to the right and 4 up. Okay, so 1 to the right, so that usually means we have to say that m would be -1, because it always moves in the opposite direction for the x values. Just like we can look at the top here, just like finding p, we saw the y-intercept is +1, the x asymptote, sorry, at +1, but yet it had to be x -1 then, sort of the opposite when we were working with the x's in a bracket. Alright, I know I'm talking, this sounds like rubbish that I'm speaking, but let's test it out. So we're guessing that m would be -1 because we have to shift 1 to the right, and q we'd guess has to be 4 because we have to go 4 upwards, right, to get 1 to the right and 4 up to get to 0, 0. So let's see if that works. Let's see if our guess worked. So if we go f of -1 minus x plus 4, let's see what that gives us. Alright, so f of x is, we started off with x squared plus 2x minus 3. Right, so now instead of x we're going to put -1 minus x. So -1 minus x squared plus 2 times -1 minus x minus 3. Let's see what this gives us. So -1 times -1 is 1. And -1 times -x is positive x. There will be 2 of those, so plus x, and plus x squared if we multiply this bracket by itself. Then we go 2 times -1 is -2. 2 times -x is -2x. And then we have a -3 at the end. And then we still want a plus 4. Right, so I forgot that plus 4. Plus 4 for the q. Okay, so the x squared is only 1, so x squared. Then the x's, so x plus x, 2x, and minus 2x, so that cancels out. And then the numbers, 1 minus 2 is -1, minus 3 is -4, plus 4 is 0. So here we go, x squared. And what does x squared look like? Exactly like what we want it to, like that. Right, x squared is just there. So that's perfect. So m is -1 and q is 4. So the m, the thing with the x, that's how much we shifted left or right, and the q is shifting it up or down. We wanted the turning point to go from -1, -4 to 0, 0. So we have to make m -1 to shift 1 to the right, and q 4 to shift 4 upwards. And there we have it. This is question 4.